All right, so you should be done with your warm-up, so let's move on. Today, we're starting a new lesson. Today, students will identify features and predict results of exponential functions. Exponential functions is something you probably have not seen before. It might look scary, but don't be scared. Okay, so exponential functions is anything to the power of x. So usually you've had like y equals 2x, okay, and that's linear. Or y equals x squared, and that's quadratic. But if it's a number to the power of x, that will be exponential. The exponential parent function is y equals e to the power of x. This is what an exponential function looks like, okay? So if you ever see something like that, that's an exponential function. Exponential growth is when it starts at the bottom and it grows as it moves along when you read it like a book, okay? Exponential decay is when it starts going down as you read it like a book. Compound interest, this is actually very, very interesting, but we're not going to get into it yet. Basically, it's how you can calculate the interest of money. Okay, it's really, really cool. All right, so let's get to our lesson here. I'm going to do the first example with you, and then the rest you're going to do on your own. Okay, so be sure to write down and understand everything that I'm doing. So out of this, they give us an exponential function written up here, and they want the domain, range, y-intercept, asymptote, and the end behavior. Okay, and they also want us to draw the graph. Drawing the graph is required. So how we're going to start this off is we're going to type in our equation here into our calculator. Okay, so go to y equals. All right, here is how you're going to type this in. Pause the video if you need to look at the steps. Parentheses, 1 divided by 2, close parentheses. Caret, parentheses, x minus 3, close parentheses. What you just did is you told it that x minus 3 up here is going to be in parentheses. Now remember, my calculator looks a little bit different than yours because it's a different version. Just be sure to follow these steps over here. Okay? Then we do plus 1. Okay? So after you type that in, let's go to our table. So second graph, go to your table. We're going to plot these points, okay, so that we can have our graph right here on our paper. So the first point we're going to graph is 0, 9. So we're going to come over here and plot the point 0, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9's above it. Okay. Let's look at our second point. The next point is going to be 1, 5. So we're going to come back and plot the point 1, 5. Go over 1 and up 1, 2, 3, 4, 5. Okay. Now we're going to go back, look at the point 2, 3. Okay, so we're going to graph our point 2, 3. So go over 2, up 1, 2, 3. Okay. Then the next point we're going to do 3, 2. So now we're going to graph the point 3, 2. So we go over 1, 2, 3, and up 2. Okay? The next point is going to be 4 and 1.5. 1.5 is 1.5, right? You should know that. You should have that memorized already. So 4 and 1.5. 1, 2, 3, 4, 1.5. Okay? From this point forward, if you look at the points, as you keep going down, it keeps getting really close to 1, but it doesn't ever actually touch it, right? Okay? So it's kind of doing this. And if you were to look at the graph yourself, you would see it doing this. It's kind of going like this. Okay? Now, a word you don't know yet is this word up here, asymptote, right? That's a new word. What that is that's an invisible line that this graph will get infinitely close to, but never actually touch. It's like this. Say you're standing right here. Okay, this is you. And you want to get all the way to the very end over here, okay? So say you go halfway between here and there. And then you go halfway again. And then halfway again. Halfway again. Halfway again. Halfway again. Halfway again, halfway again. You never actually reach that point. You get exponentially close to it, but you never actually touch it. That's what an asymptote is, okay? It's just a line that's invisible that this line will get exponentially close to but never actually touch. Okay, so let's do our domain. Domain. How far to the left is this line going to go? Yeah, infinity, because remember it's got an arrow, so that's going to keep going and going and going. So it's going forever to the left, and how far to the right is it going to go? Infinity. So our domain is all real numbers. Okay? Next thing, let's look at range. So range, how far down is this going to go? How far down does it go? It goes to 1. Does it actually touch 1? No, it doesn't. So you do not put that equal sign under there. How high up does it go? Infinity. So we don't have to put that, okay? Because we know it goes on forever. So the range is going to be y is everything greater than 1. Okay? So now let's look at our y-intercept. Here's a real easy way to find your y-intercept. You ready? Go to your calculator. In the table, when x is 0, that's your y-intercept. Real easy. When x is 0. So what is our y-intercept here? 9. So you write it as parentheses 0, 9. Parentheses. Okay, don't forget your parentheses on your point. So now for our asymptote that we were looking at earlier. Our asymptote. Okay, where is our asymptote? At 1, right? It's this line, this invisible line that goes through here at 1. So we would write it as an equation, y equals 1, because it goes through y here at 1. Okay, so that's your asymptote. The last thing we're going to look at is the end behavior. So when you read this like a book, from left to right, is it going up or down? Down. So is that growth or decay? Decay. So it's exponential decay. And that's it. So this is how you fill out the entire sheet. If you have any questions, come and ask me. You are expected to do the work. If you need to know a definition of something, go back to the vocabulary.